Good morning, grade 10s, and welcome to this morning's online class. As per custom, you know that I always allow a few minutes just to make sure that everyone who wanted to join us did join in. So let's just give them a bit of time. See you just now. Right, it seems that everyone who wanted to join in did join in this morning. If I didn't greet you yet, welcome to this morning's Mathematics Online. There we go. For those of you who don't know me yet, my name is Linky Young and I'm the Education Specialist for Mathematics and Sciences at Impact. So before we jump in and start off this online class, I would like to cover some basics so that everyone knows what is expected of them and what to expect from the session. So if you're struggling to hear me, please make sure that your audio is on and that your speaker volume is turned up. Right, you will automatically be muted when you join into the session. So you know how my sessions work. If you don't know, I will allow some time where you can ask your questions. I will unmute you, you can ask your question, and I will mute you afterwards again. You can make use of the hand icon, and I will prompt you throughout the session when you can use it and when you should not use it. That's a little hand icon there on your dashboard. If you want to, you can quickly try it out. Click on the icon, it will put up your hand. And you can also click on it again to take down your hand. Quickly test it out. There we go. I see that there's a few of you testing it out. All right. You can download this presentation and additional resources in the handout box for you. So for today, I've added this presentation in PDF form and I've added an extra question. So please make sure that you download that today during the session, as if we stop the broadcast, it won't be available for download on this platform anymore. So please go to your handout box and download the two resources that is uploaded there for you. You are welcome to send us your questions, and remember, I'm going to ask you throughout the session. If you're still fine, you can ask your questions over there. We do encourage all our attendees to leave questions or comments, but should you leave irrelevant or inappropriate questions, you will be dismissed from this session. If you have any academics questions still after the session, you're welcome to send an email to academics@impact.co.za. Usually we get through all the academic questions in a session, but should you have any more, you're welcome to send an email to academics. You're also welcome to leave your questions in the question box if you're not comfortable to ask your questions out loud. During the session, I also make time to go and have a look at those questions and answer them to the best of my ability. So if there are still questions that we didn't get to, I will send you an email with the answers to those questions during the week. If you don't get that and there was unanswered questions, you're welcome to send an email to info@impact.co.za. All the previous recordings of sessions can be found on Impact's website, and at the end of the session, I'll show you exactly where to go. Right, just a reminder to quickly download those handouts for you. As I've mentioned, I've added an extra question that you can do on your own for practice, and I think it will be very beneficial for you to work through that. Right, quickly put up your hands. Please show me that you can hear me and that you are ready to start off this session. Thank you. Seems that most of you can hear me and that we can start with this session. All right, I'm going to type down the hands for now. I will allow some time later in the session where you can also make use of your hand icon. So for today, I'm going to do Euclidean geometry. Now, Euclidean geometry, you will see in your work schedule, is actually divided into two parts. The first part is grade 9 revision, and then all the grade 10 work that follows. So for this term, if you are registered at Impact, we only spend a bit of time on the revision of the grade 9 geometry. So from term 3, we jump and we do full-blown grade 10 geometry. Okay, so if you are not registered with Impact and you signed in for today, you're welcome to look at the revision of the grade 9 geometry. You will need it for your grade 10 geometry. And then from our next online lesson, we will then do grade 10 Euclidean geometry. Right, so Euclidean geometry, you will be assessed on that in paper 2. So in paper 1, you won't see any Euclidean geometry. So don't spend time on preparing Euclidean for paper 1. You should only prepare Euclidean for paper 2. So all the topics that you have to cover in Euclidean is the revision of the grade 9 geometry, and that includes lines, angles, and triangles. Now with the triangles specifically, I want you to go back and make sure you know what similarity of triangles are, as well as congruency and how to prove that and what is the reasons that a triangle can be congruent. So at the end of the session, I've also included some extra links for you. One of those links is a whole lesson about the congruency of. So please take the time and go through those links that I've added there for you. Then we will look at the properties of a line that connects the midpoints of triangles, and that is the term 3 work that we will do in our next. We will also look at defining the following special quadrilaterals. So we'll look at a kite, parallelogram, rectangles, rhombus, square, and the trapezium. All the characteristics that these shapes will have. This quadrilaterals. Quadrilaterals means shapes with 4 sides, and how we can actually use those characteristics when we do Euclidean geometry. As I mentioned, we will just look at the revision of grade 9 Euclidean geometry. So for today, I thought it well to take a grade 9 final examination paper, so the November paper, and see how this Euclidean geometry was asked. Why have I done this? Now, it is not only the theory that you need to know. You need to know how to apply these laws and rules of Euclidean geometry that you need to revise. And this doesn't mean that you won't find this in grade 10. Questions like these can appear just as is in grade 10 as well. So I think this is a good place to start. Let's see how it was asked in grade 9, just to, spark up all the old memories and all the old knowledge that you have regarding Euclidean geometry before we move on to grade 10 work. Right, so as I mentioned, I have taken old question papers. So I did a bit of research and went to look at stuff that you can't just find easily, where we usually look for old question papers. And I came across this paper from 2018, and it's the November examination of the Eastern Cape for grade 9. So the common paper that I wrote over there. And this is an excellent way to actually remind you about a lot of laws and a lot of theories regarding Euclidean geometry and how we can actually apply that. Okay, so let me just get this nice indicator over here. Okay, so question 5 said, in the diagram below, AC is parallel to HF. So do you remember those two lines that we draw vertically represents parallel? And parallel lines means that they will never cross each other. They have the same gradient. Okay, so they say that the line AC, here it is parallel to the line HF. And for your convenience, they actually indicated that using an arrow. So there's one arrow on each of them. It means that they are parallel to each other. So before I move on, I want to let you think a bit. So by giving you this piece of information, they actually give you a tip of how you can actually find angles. And there's a lot of theories that actually goes together with parallel lines, looking for common angles, looking for co-interior angles, looking for alternating angles. So all of that angles actually goes hand in hand with parallel lines. So all of those theories you can actually use to answer your questions just by them giving you this tip that AC is parallel to HF. Okay, then they also say that BF, the line BF, which is over there, is parallel to the line CD. And they've also indicated that for us. So do you see both of them have two angles over there? So one arrow, and then two arrows over there. Now you will see they write this a little bit different than in Gauteng. So we would have written C, B with a hat on there, okay, F, to show you that B is the angle. In the Eastern Cape, and I know there's other provinces as well that use angle CBF. So how you should think about this is just walk what they give you. So you start with the C, B to F. And you will see that that's the only angle that it makes, CBF. And they say that that angle over there is 85 degrees. Okay. The next one is angle GFH. So GFH is equal to 50 degrees. And they have included that in our drawing as well. Okay. So with all of this information that they've given you, they want you to calculate X. So there is X. Now, of course, there will be more than one method to do this, and you're welcome to use any of the methods that you would like if it is mathematically correct. So meaning if the theorems that you use and the rules that you use is correct, even if it takes longer or shorter than what I'm showing you, it is fine. You should just remember that everything you do should be a statement with a reason. And those reasons should be mathematically. So I can't say X is equal to 50 degrees because it looks the same. Okay, so that is not a reason. You should go and revise all the different types of angles that I get, as well as the different lines that I get. Okay. For what is given here to me, here for me, I can see that I have parallel lines and a line connecting there. Now, we talk about the Z. There we go. So it is the line from a parallel line to a connecting line to the parallel line that is parallel to the original line that you started with. And that angle, that Z that it makes, is your alternating angles that we talked about. And I'm sure that you can remember that from grade 8. And then you can say, but X is equal to 85 because of alternating angles. And you must remember you need to tell them which two lines are parallel to each other. Which two lines causes you to be able to use alternating angles. So you can say X is equal to 85 degrees, alternating angles with line AC parallel to line HF. Okay, and you can write it like this. Now you will see there at the top, I said, remember your reasons, and this is why. Okay? You will get a mark for your answer, but you will also get a mark for your reason. You've already done the thinking, just write it down. Otherwise, you lose 50% of your marks already. So remember to add a reason with your answer. So we said that it's 85 degrees. You get a mark for your answer. And then we said alternating angles with line AC parallel to line HF. And there you get a mark for your reason as well. Okay, so next up, they ask you to calculate Y. And again, there's different ways that you can do that, longer ways, shorter ways. But there's one specific theorem that actually works very well with stuff like that. That is when two angles are on the same side and they are actually boxed in by two parallel lines. So we worked with these two parallel lines previously, but now I'm going to work with BF and CD as parallel lines. And you can see it makes a nice box over there. When I have boxed in angles between two parallel lines, I work with co-interior angles. Now, the theorem of co-interior angles means that the sum of the two angles are equal to 180 degrees. Now, you will see that they didn't write it all out and all the steps of how to actually get to that. So you would say 85 plus y is equal to 180 degrees. And that your reason will be co-interior angles is 180 degrees. And remember to tell them which two lines is parallel to each other and caused you to be able to use your co-interior angles. And then if you solved 95, you would have solved y, you would have gotten 95. So let me see, I'm not sure how this will work. So you will start off by saying y plus 85 degrees is equal to your 180 degrees. And that is just because of your co-interior angle. So you can start off with this, and then you can take your 85 over to the other side. So y is then 180 degrees minus your 85 degrees, and then you will get to y is equal to 95 degrees. Okay, so in the end, you've done those steps and it helps you to think through the process, but you will get a mark for your answer and of course for your correct reason. Remember to include the 2 lines that causes you to be able to do that, your 2 parallel lines. All right. I am going to stop here for now. Is there anyone that has a question regarding question 5.1? Please put up your hand. Okay. Michael Matthews, good morning.
Good morning, ma'am.
How are you?
Good, and you?
Good, thank you.
So I've got a little question. I'm looking at your paper here, and I see the way I worked it out was a little bit different to the way you got the answer. I'm not saying you're wrong, and I'm not saying I'm right either. However, when I look at it like this, angle, if I take angle on a straight line from 85 degrees, and I minus the 85 degrees because it's a straight line. I minus that from 180. That gives me 95 degrees. That would then state that angle ABF would be 95 degrees, right?
Correct.
Okay. So then, I don't know if I'm right. So then 95 degrees, that would then mean angle GFB would also be 95 degrees. Or is that wrong? Because then I'll take 50 degrees minus 95, and that would give me 45 degrees.
Okay, so you can't say that because they didn't give us information regarding this line, this GFD. So we don't know if that is exactly at the same angle as this one and so on and so forth. So we shouldn't just assume something, especially with Euclidean geometry. If they don't give us specific information regarding that, please don't use that. And if you can't prove that mathematically, it probably isn't correct. And I'm saying this for everyone, please listen up very carefully. You can get drawings, diagrams, where you can put your life down and say, but this angle is 90 degrees. I've measured it. I can see it. But nowhere it was stated that an angle is 90 degrees, or you could have proved it 90 degrees with your theorems, then you can't assume it 90 degrees. So it's very dangerous to just assume things in Euclidean geometry. What you could have done, Michael, and I was excited because I thought that's the route you're going to go, you actually said here, now of course this is 95 degrees with a line on angles on a straight line, right?
Yes.
Then you could have said, but this angle that you've calculated and y over here is the same because it is common angles.
Yeah.
You see, I have 2 parallel lines and they have this line through that. So these 2 are common angles. Okay.
Thank you.
All right. Pleasure. Right, Michelle Chetty. Hi, Michelle. Michelle, there you go. Michelle, do you have a question? Okay. I'm going to move on as we can't hear her at the moment. Okay, let me just check the question box over here. All right. Okay. Guys, I think that I am going to move on. It doesn't seem that there is any more questions for now. Okay. Right. So the second part, so 5.2, now says that the diagram below is triangle MNO. And there you have MNO. MNO with the line MN parallel to QP. And they've also indicated that for us with arrows so that we don't forget. Now they say that the angle OMN is 55 degrees, and they've also added that information for us on there. And then they say angle QBO. Okay, is 3x plus 40. And then, of course, angle MON is 2x minus 5. So I just want to show you that it talks about this angle over here. It just wasn't big enough to, or small enough to fit it in over there. Okay, so they've given us all of this information, and they have indicated all of that on this diagram for us. Okay, so again, you have two parallel lines that of course tells us a lot about the angles that you can see, and now the introduction of a triangle. So all of the laws that goes hand in hand with a triangle, stuff like the sum of the interior angles of a triangle is 180 degrees. The exterior angle is equal to the sum of the two opposite interior angles of a triangle. Okay, so all of those things come into play now because I'm working with the triangle. So now they say, calculate the value of x. Give reasons for your answer. Now, x is part of two of the angles of a triangle. So just looking at what I have over here, I won't be able to get interior angles that will actually help me. I won't be able to use alternating angles because there's not a line connecting the angles. Okay, but there's something else, and Michael actually showed you this in the previous question that we've done. So I have these two parallel lines, and I have a line going through that over there. So MO goes through these two parallel lines. So if I look at M, which is 55 degrees, the angle M, I know that Q1 is actually 55 degrees as well because of common angles. Okay, and the two lines that actually allow me to do that is this parallel line MN and the parallel line QP. All right, so I could say that Q1 is 55 degrees. Now I have all of the angles of this triangle over here. And I know that the sum of the interior angles is 180 degrees. So I can add all of these angles together, equate them to 180 degrees, and then solve for x. So let's see how it is done. So first off, you will see that they talk about Q1, which is 55 degrees. And we said that, and we can see that Q1 is 55 degrees because of corresponding angles or common angles, right? They have the same properties. And this is actually true because MN is parallel to QB. Okay, here you get a mark for making the statement and your reason. So if you left out your reason, you wouldn't have gotten any marks. You would have lost out on this mark over here. Okay, then I said, now you have all three of your angles over here, and you know by adding them together, it should be 180 degrees. Why? Because the sum of the interior angles of a triangle is equal to 180 degrees. So you will say 55 plus 2x minus 5 plus 3x plus 40. And then you can just solve for x. Okay, so you take all your common variables to the one side. So 2x plus 3x is 5x. And then 55 minus 5 is 50 plus 40 is 90 degrees is equal to 180. So you take the 90 over and you divide it by 5. You will get that x is equal to 18. Okay, so let's just see what you get marks for this step. So you get marks for the statement that you made, if it's correct, and of course a mark for your reason. So do you see how important is your reasons? It counts just as much as the statements that you have done, okay? And then you will get a mark for your final answer. So this CA is just if you made a little calculation mistake over there and it's not mathematical, you will get that mark as well. All right, so let's move on. Then they ask, now calculate the actual size of X, of this angle, sorry, of angle MON. So they want the actual size of this angle. How can I get that? I do have my X value over there now, and I can just substitute it into this equation. So you can see they say MON, the angle MON, was said to be 2x minus 5. I did calculate x in 5.2.1, and I'm going to substitute it into the x minus 5, and then your answer will be 31. So if you maybe made a mistake over there, and you've taken your answer, your incorrect answer, and substituted it in here, you will still get your mark. So this is for the method. They want to see that you took the correct value. Even if you calculated it incorrectly, you substituted it, and then you made the calculation correct to the final answer. Okay, so this is the 2 marks that you will get for this question. Right. Any questions regarding question 5.2? You're welcome to put up your hand. Let me see if you have any questions. Right, Isabella says that Q1 should be 55 because they are corresponding angles. Well done. That is exactly what we said. Angle N should be 94 because there are corresponding angles M, N, Q, P. Okay, so it will be 3 times 18 plus 40. It will probably be 94. Well done. Remember the angle that I talk about here, or the triangle that I refer to, is this triangle over here. So triangle QPO. This is the triangle that we used in our calculations. Okay. I just want to make sure there's nothing else over there. I'm quickly moving over to the hands that is up. I saw something there. Michelle, your hand is still up. Do you have a question? Michelle? Michelle Chetty? Let me see if there's anyone else with a hand up over there. Okay. Right. It seems that I have answered all the questions regarding that now. Isabella, you can just post if I did answer the question and that you're fine with my response to what you've posted in that question box. Okay, let's move on to the last one over there. So 5.3, they say the diagram below is a rhombus. Now, this is what you need to know, all the characteristics of a rhombus. So a rhombus has 4 equal sides. The 2 opposite angles from each other are equal. And I know that the diagonals of a rhombus actually halves the angles that it goes through. So they say that this is a rhombus ABCD with diagonal BD. AB is extended into E and angle A is 70 degrees. So they didn't write it on the diagram. You are welcome to write it as 70 degrees on your diagrams when you do your tests. Please do so, because sometimes they do give you information that they didn't indicate on the diagrams, and you actually need that information to do your calculations. Okay, so 5.3.1 says calculate with reasons the size of angle ADB. Okay, so I have this 70 degrees over here. And I know that the sides of a rhombus are equal. So if I look at this here, it's actually a triangle that's given here for me. And it is an isosceles triangle where I have two equal sides. What do I know about the angles in an isosceles triangle? They are equal. And I also know that the sum of the interior angles of a triangle is 180 degrees. Now I'm going to first write it out over here terribly with the mice so that you can just see my thinking. So I have this 70 degrees that was actually given to me. And I know that this angle here is equal to this angle here because of the isosceles triangle that I have going on, because of the characteristics of a rhombus. And I know that if I add them all together, I need to have 180 degrees because it's the sum of the interior angles of a triangle. So let's just for explanation, let's make this x. Because I know they are the same, I can make this angle over here also an x. So 70 degrees plus x is equal to 180 degrees. It's because I need to get the sum of the interior angles of a triangle. So if I just simplify this a bit, I'll get 70 plus 2x is equal to 180 degrees, right? So solving x will actually solve the value of this angle over here. Do you see how your algebra is creeping in everywhere? Okay, so you'll say 2x is equal to 180 degrees minus the 70, so you'll have 110 degrees. 2 times that, 2 times x is 110, so x will then be equal to 55 degrees. Okay, so this is just the thinking that I want you to follow. Let's just look at exactly how you can write that down. So there's actually different ways that you can do that, and they say that the angle ADB, do you see ADB, because they didn't number the angle, so you'll say the angle ADB plus the angle ABD is equal to 110. And this 110 just comes from your 180, which is the sum minus the 70 degree of your angle A. Okay, but they say that the two angles are the same because it is an isosceles triangle, and therefore it is 55 degrees. Okay, so it's easier to understand this method if you looked at what I've shown you previously. So what I would recommend is that you actually follow the steps that I followed with the correct reasons. Again, do you see you get a mark for your statement and your reason together? So if one of them are missing, you won't get the marks. That happens twice and you only get 1 mark for your final answer. All right. So 5.3.2, calculate with reasons the size of angle AD, sorry, I missed it, the ADC. Okay, so just thinking about a rhombus again, I know that my diagonals actually halves my angles, my vertices over there. This means that this angle over here is just as big as this angle over here. Okay? And I also look at alternating angles that you get, and I know that this angle here will be the same as that angle over there. Okay, so just for interest's sake, the theory that we actually use is that the diagonals will halve the angles in a rhombus. Okay, and this is exactly what they've done. I know what the value of D is. So to get the value of ADC, this entire one, I can just multiply that with 2. And there you have it. So you have your statement. Diagonals of a rhombus dissect each other, so it will be twice that value. Right. You will see that there is other options as well where they work with co-interior angles. So when you have this A as 70 degrees plus this D angle should be 180 degrees. You see the box that we talked about with co-interior angles. So you will say 180 degrees minus the 70 degree will give you that entire angle over there, which is 110 degrees. So of course, and like I've said previously, there is more than one way to get to the answer. The rule is just that you need to give your reasons and motivate your steps to get there. Right, 5.3.3, calculate with reasons the size of angle DBE. Okay, so DBE is this angle over here. And this is the exterior angle of triangle ADB. Okay. And what do I know about the exterior angle of a triangle? It's equal to the sum of the two opposite interior angles. And I have the angle A and I have the angle D over there. And that is equal to 90 plus my 55 degrees. You will get 90 plus 55 is, 70, not 90 degree, is 70 degrees. 70 plus 55 will give you 125 degrees. Again, you get a mark for your statement and a mark for your reason. 5.3.4 say that you need to give a reason why ABD, so ABD is equal to BDC. Okay, I'm quickly going to clear these drawings. Okay, so they want to know you need to give a reason why this angle is equal to that angle. Okay, do you see that they are alternating angles? Okay, so you can say that ABD is equal to DBC, alternating angles. Why are they alternating angles? Because I have two parallel lines and you need to tell them which two lines are parallel. So you can say DC is parallel to line AB over there. Okay, and you can write it like this. Okay, so they say the opposite sides of a rhombus are parallel. You could have just said that CD is parallel to AB with alternating. Okay, is there anyone that have any questions? You're welcome to put up your hand. I'm quickly going through to the question box while I'm waiting. Okay, Isabella, I'm happy to help. Okay, well done. Okay, no one else, no one putting up their hands. Okay, so this concluded all of your grade 9 Euclidean geometry. I really want you to go and look at the extra question that I've added in your handout. So please download that. I've also included the answers at the end of the question So work through those questions, think about all of these characteristics, all of the theorems that you've learned, apply that and see how you are doing. Now, again, this is a grade 9 paper because we're doing grade 9 revision for today. There we go. I did ask if there's any questions, but there was no questions now. Please put up your hand if you do have a question. I'm quickly going to just double check. Okay, Muluanto actually asked us to explain 5.3.3 again. Okay, so they want us to calculate the size of angle DBE. And DBE, let me mark that for you, is my exterior angle. So the exterior angle of a triangle is equal to the sum of the two opposite interior angles over here. And we've calculated that it was given that A is 70 degrees, and we've calculated that this angle ADB is actually 55 degrees. So if you want to calculate this angle, you will say 70 degrees plus your 55 degrees, and that will give you your 125 degrees, and your reason will be the exterior angle of a triangle. Okay, so there you have your exterior angle of a triangle is 125 degrees, and it comes from the sum of my two opposite interior angles over there. Okay, any other questions that I can assist with? Okay, I see that there's a hand up over there. Let me just go through that. Michael?
Hello. I'm still struggling with the past webinars, the work that we learned about, I forget now, but it's about, let me just open it up, about the functions of straight lines, and I don't know what to do to get extra help for it.
Okay, Michael, you're welcome to send me an email, all right?
Okay.
Just send an email to academics@impact.co.za with a specific question that you're struggling with, and then I can explain that through to you.
Okay.
Okay. Okay, Tatu. Tatu, do you have a question this morning? Okay, Tatu, can you hear me? All right, I'm going to move on quickly. All right, it seems that there's no other hands up. Just make sure there's nothing extra in the question box. Okay. Right, I'm going to move on. So here you will see the 3 links that I talked about. Please go through that. It talks about lines, angles, and then of course triangles, specifically to congruency and similarity of triangles. Please look at those videos. Then I've also added links that is impact videos that is also on the guided learning platform. You're welcome to have a look at that as well. So Agatha asks, how many marks does it cost? Agatha, I'm not sure what you are referring to. If you can just type that out for us, then I'll come back to your question again. Here is what I've mentioned, that you can get all the previous recordings on the Impact website. You're welcome to go on there and just go and have a look at our previous webinars, should you like to. Michael, it's only my pleasure. Okay, Agatha, I didn't get any Any response from you yet? There you go. In Euclidean geometry will be a third of paper 2, so it's quite a lot. It's 33% of the paper, if not more. But the guideline and the requirements of a paper is actually that it should count 50 marks. So that is a third of the paper. So it is quite weighted, and you will have a lot of marks over there. So she says it's a strong point, so that's good. Now you know you have a head start in paper 2. Right, grade 10s, if you're not registered at Impact and you would like some more information, please go to info@impact.co.za and send them an email so that they can send you some more information. Yeah, I see something popped up in this question box again. For this online schooling, do we write the exams at your school premises? Kanyo, I'm not sure if you're a new registered student, but you're welcome to send an email to assessment@impact.co.za and they will be able to answer all your assessment questions. Okay. Right. Grade 10s, thank you so much for joining in this morning. I hope that you learned something today and that we woke up all of those Euclidean geometry from grade 9. And study hard, work hard, be healthy, and enjoy the times with your family. Have a lovely day. Bye.